You have swiped so many popular science videos. Do you know what an electron is? If we keep zooming in, is it a sizable electric crane power? It's a multi-dimensional vortex of quantum singularity. Is he the one who owns his own electricity? The boundaries of the tiny universe of children. I am an old horse. Today, let's explore the wonder of electronics. In fact, nothing is simpler than electrons. According to current theory, it is basic, one of the particles. It's not made of smaller things. It conjures up images of a single point, or it could be one made of charge and mass. The ball doesn't have much else. They look like atoms in cartoons. Electrons are orbiting, like a ball. In all popular science videos, what you see is just a simulation. It's not really accurate. Maybe you know. In quantum mechanics, examples don't exist as tiny chunks of matter. It exists as a wave function. Fuzzy distribution. It defines the particle when it is measured. The probability of where or what might appear, such as circle. Electrons in a child, more accurately depicted as a blurry shell. It's not an orbiting ball. And free electrons. It may look like able to interfere with itself and perform other wave-like activities. These fluctuating structures, for things like photons, seems more intuitive. A photon is actually a wave in an electromagnetic field. Its most important properties, such as frequency and wavelength, can be captured in terms of fluctuations. But electrons have mass. He has an electric charge. He has his own right to these properties. How does it exist in the fuzzy wave function? There was a brave attempt to represent the electron wave function. Space component. In particular, the spin or wave function, what we are discussing here. But these are all attempts to visualize a rather abstract concept. It's not what electrons really look like. So let's really zoom in. We actually never see the fuzzy wave pack. Because when we measure, electrons will exhibit precise attributes. Observation of electrons means analyzing its location and spatial structure. As we measure more precisely, the wave function shrinks to something like a particle. But how much can we scale up? We will eventually see a tiny ball. It's an infinitely small amount of electricity, the power of personality and quality. Where does that electric crane and mass live? What do electrons really look like? There is a complex theory underlying these issues. Read to zoom in and see what the electron looks like. Will reveal some puzzling contradictions. Let's first try to use fine point physics builds an electron. We pass through the universe around us, collect enough greetings, and bring them together to make it happen. According to Coulomb's law, electric cranes of the same species repel each other through Courant. Coulomb's law tells us that the more we try to bring the two cranes closer, the more force is required. This means assuming same amount of charge, aggregate the charge into a more compact ball, requires more energy than a scattered ball. With a little knowledge of calculus, we can calculate a quantitative charge. How much energy does it take to form a ball? This energy, it is to seek the potential energy possessed after gathering. Smaller is more energy. According to Einstein's theory of relativity, we know that counting negative energy equals mass, easily equal to the square of mc. So now we can ask, if we take the electrical charge of an electron, gather into a small enough ball, make its potential energy equal to the known mass of the electron, how big will it be? That's about 2.8 times 10 to the minus 15 meters. This is the classical electron radius. If the mass of the electrons comes entirely from the charge it contains, well, then the electron must be of this size. But that's not the true size of an electron. Our experiments tell us. The true size of an electron is less than 10 to the 17th meter, at least 100 times smaller than the classical electron radius. But if we continue to move the electric ball, compressed to that size, then the mass equivalence of potential energy is the actual electronic force. Then the actual measured electronic quality, 511,000 electronic force, 20,000 times bigger. If our electrons, it really is an electric crane without size, then the denominator of Coulomb's law becomes zero, and the energy accumulates all the way to the center point, infinite now. The electron is not a mutually exclusive ball of electricity. His electricity and self interact in complex ways, exhibited in the quantum field activity around the electron. Come out as we shall see. But the equations and numbers I came up with still gives a greeting from the same size. The energy contained in the electromagnetic field emitted by the number. Therefore, this energy still contribute to the observational quality of electrons. Electronic power plant contains much more mass than the electron itself. Or at least it used to be a real problem. Even if we move from classical mechanics to quantum mechanics, the problem still persists. In quantum field theory, we use quantum fields activity to describe electromagnetism. Every elementary particle are all stimulated by their own quantum field. So the photon is excited by an electromagnetic field, while electronics and the positrons are the excitation of the electronics factory. Quantum factory, sometimes described as a sea of tumbling virtual particles. They appear and disappear. It's not very accurate. Instead, imagine a quantum. When a field encounters a real particle, potential for complex and random fluctuations. These fluctuations can be modeled with virtual particles. As a mathematical tool, we can use virtual photons in electromagnetic fields to simulate currently. They transfer momentum between charged particles. Or we can use virtual photons transformed into virtual matter, antimatter vs. electrons, positron pair, to simulate spontaneous transfer of energy between electromagnetic fields and electronics factories. In this case, if the electromagnetic field in the quantum theory, at least mathematically virtual brilliance, what would the ocean look like? From a distance, the activity of these virtual photons are averaged to the smoothness described by classical electromagnetism. But when our magnification reaches a certain point, it's about 100 times the radius of a classical electron. We are transitioning to A, regions where the quantum behavior of fields cannot be ignored. For example, as the field strengthens and our field of vision shrinks, we see electromagnetic fields and electronics factories. The interaction between them has been strengthened. We can describe this as a pair. Increased rate of production, active flickering of virtual photons, and the virtual electron-positron pile they generate. This active cloud looks like the closer we get to electrons, the stronger he is. It's not just that we see more quantum properties of strong electromagnetic fields to detect the behavior of electrons coming so close. It self-amplifies quantum fluctuations. The Heisenberg uncertainty principle tells us that the accuracy of space or time measurement, certainty, causes uncertainties in momentum and energy increase respectively. The more accurate our snapshot of the electron is, the more intense the quantum fluctuations we observe. We are in this video. This effect is discussed in more detail. But it turns out the universe is explored on a scale. It looks very different. It's the same with electrons. although somehow all scales weave into a unified feature. So we're at a very small scale, much smaller than the classical radius, obviously bare cushions. It seems to be surrounded by this virtual activity cloud. This dress, it's our energy, and a source of extra mass for electromagnetic fields. As we get closer and closer to electrons, the energy in the field approaches the resting mass of the electron. A new interaction becomes important. Now virtual electronics, positron teammate, quite likely, interacts directly with the real electron at the center. Sometimes a virtual positron, in fact, it will be extinguished from real e-cigarettes, then its former virtual partner, electronically, elevate to reality. It's as if the original electron has changed position. This has two important implications. The first effect is, this effect actually saved the electrons, save it from being predicted as huge by classical physics, even infinite mass. The second, self-annihilation, cooperates with each other. The impact of the roll is, no matter how much we zoom in, we actually can never see the electrons clearly. The more we zoom in, the stronger the surrounding virtual wave cloud, the more these interactions occur. At some point, the electron becomes a blur. We will never be able to determine its location. Mass is eventually replaced by energy. Mass and Heisenberg uncertainty smoothed out. The charge of the electron is also smoothed out by the latter, even before we get close to the central electron. Virtual electronics, the positron team is smoothing out that charge. Those pairs interact with the surrounding electromagnetic field. Positrons tend to, closer to the center. Virtual electronics go even further. This so-called vacuum melts happens around the central electron, and there's shielding the universe. Effect with the central Hertz. In fact, as we approach the center, the observed charge should appear to increase. Beyond this block, if you calculate small distances from wireless, all effective electric crane shielding to the center electric crane. So the central crane has to be wireless. This means that the central electron itself needs to have a wireless electric crane to overcome that wireless shielding. Of course, we now know that we will always, far from being able to detect an electron, fully positioned point so that wireless might not make sense. However, if it is true, when the crane shield is overcome, the electromagnetic force increases over very small distances, even if we can't be in our infinite. We're zooming in and catching our electrons. This elusive example, at least mathematically very understandable. We even know how to save the electron. Save it from squid, interaction with surrounding quantum factories, and explodes its mass and charge. Although to understand this, we need a tool called renormalization. We will soon explore. We will also see this tricky question about electrons foreshadows a bigger puzzle in physics. Hierarchy problem. We will encounter that have not been rescued from this problem. So the electron is not as simple objects that can be seen directly. It's a complex quantum entity. Its nature and behavior deeply influenced by quantum mechanics and quantum field theory. The true appearance of ringing electrons is obscure, dynamic, and it is radically different from our everyday experience. If you don't understand, like it,